Alright, so we'll pick up there from 4.3. So these are factoring problems. The first thing you should always do with every factoring problem is you should see if there's what's called a greatest common factor. So if you look at number 5, you look at the numbers 3, 3, and negative 90, they all have a common factor of 3. So I'm going to pull that out. How do we get what's left behind? We basically divide each of these things by what we pulled out. We pulled out a 3. So 3n squared divided by 3 is that. 3n divided by 3 is n. And negative 90 divided by 3 is negative 30. Now it says factor completely. This is not completely factored. I want to ask myself, what numbers multiply to negative 30 and yet add to, this is really a positive 1 right here. So I know it's going to be n times n, that gives me n squared. I also know that if it multiplies to a negative, one of these numbers has to be positive, one has to be negative. What multiplies to 30 but has kind of a difference of 1? Well, that's going to be 6 and 5. 6 times 5 equals 30. And then where is the signs going to go? Well, negative 6 plus positive 5, that would be negative 1. I don't want it to be negative 1. I want it to be positive 1. So 6 plus negative 5 is what works. So the negative will go here. The positive will go here. Now it's completely factored. And you could check to see if that's correct by foiling this out. If you did first, outer, inner, and last, and then multiplied it by 3, you should get back to where you started, and you will. Okay, number 6 is the same type of problem. So number 6, we're looking for numbers that multiply to this number. We want to multiply to that, and we want to add to this. So it's going to be x times x. What kind of numbers multiply to a negative? Well, 1 is going to be positive. 1 will be negative. And then if I go through the things that multiply to 14, so if I had negative 1 times 14, negative 2 times 7, those are the only things. These two numbers don't add to 5, but these two do. Negative 2 plus 7 adds to 5. So you can again check to see that this foils out to be what we started with, and it does. Number 7 is kind of like number 5. In number 7 we want to look for another greatest common factor. And the greatest common factor right here is, well, this is a 1, so the greatest common factor of 1 and 6 is just 1. The greatest common factor of x squared and x would be x. That's, in other words, what power of x do they both have in common? They both have an x to the first in common. So I'll pull out an x to the first, then I want to divide each of these by what I pulled out. So x squared divided by x to the first is just x. 6x divided by x is 6. And this is now completely factored. You can test it, you can distribute this, and you'll wind up back where we started. Number 8 is factoring. This one's tougher because the original number, this number right here, is not 1 like it was on all the other problems we've done up here. So there's a couple of different ways you can solve this. One of the easiest ways to solve this is using something called the swing method. And the proof for this is kind of complicated, but this does work. If you take this number, you start by swinging it over here, which means multiplying it. So I swung the 6 over, so it's not there anymore. 6 times negative 10 is negative 60. And now we're doing a problem exactly like what we did right before. So this is the same as this problem right here now. So we need to find numbers that multiply to negative 60 and add to positive 11. So first of all, they're multiplying to a negative. One will be positive, one will be negative. And it turns out that the numbers that do that are 15 times 4. 15 times 4 equals 60. To get positive 11, that means the 15 has to be positive, the 4 has to be negative. Okay, here's the problem. We're not done right now, because if you were to FOIL this, x times x is not going to take you back to 6x squared. So here's how to think about this. The 6 that we swung over, where was it? Well, it was in the 60, which means it's in these 15 and these 4 right here. Since we got the 6 there by multiplying, we'll get it back by doing the opposite. We'll get it back by dividing out that 6. Then we want to reduce these two fractions if we can. So 15 over 6, well, 3 goes into both of these. 3 goes into 15 that many times, goes into 6 twice. 4 over 6 can be reduced to 2 over 3. This still won't FOIL out to be 6x squared, but this is why it's called the swing method. You take these numbers on the bottom and you literally swing them in front of the x. So we have 2x plus 5. We have 3x minus 2. This is now completely factored. You can test that and FOIL it out, and if you do, you get back to what we started with. Alright, number 9 and 10. Number 9 is another swing method problem, so we'll take the 6 and swing it over. This number is a little bit more tricky. We're looking for numbers that multiply to 180 and add to 41. We know that this is positive 180, so they're both going to be positive. They're both going to be n plus something. And then the numbers that turn out to do that are 36 times 5. 36 times 5 multiplies to 180. 36 plus 5 adds to 41. Again, let me change color here so we can see this a little better. Again, the question is, where did the 6 go? The 6 went into the 180, so that means it's still in the 36 and the 5. So I need to divide it out. 36 divided by 6 is just the number 6, so that simplifies. And then I can't simplify this anymore, so I'm going to take it and swing it in front, and it becomes 6n plus 5. You can once again FOIL this out, and you will wind up back what we started with, 6n squared plus 41n plus 30. This last factoring problem, this is what's called a difference of squares. Notice that if we write standard form above this, there is no bx term. It just has an x squared and just has a number. So the pattern for factoring those types of problems is, it's called a difference of squares. Let me write that. Difference of two squares. The reason it's called that is because 16x squared, that's a square. That's 4x times 4x. 49 is a square. That's 7 times 7. And the way that you get the middle term to disappear is one of these is plus and one of them is minus. And you can test that out. If you FOIL it out, you get 16x squared. 4x times negative 7 is negative 28x. 4x times positive 7 is positive 28x. Notice what happens. Those cancel each other out. And then 7 times negative 7 is minus 49. So that's a good way to check. Number 11. Okay, the only difference with these problems is this question say solve by factoring. Okay, on the previous page, we didn't solve anything here. All we have is just factored things. But a solution, when it says solve, your final answer should be x equals something, or in this case, n equals something. So let's factor this. We want numbers that multiply to negative 6, but add to, that's a negative 1. Numbers that multiply to a negative, one will be positive, one will be negative. And it turns out to be 3 times 2 is 6, but we want these to add to negative 1. So the 3 has to be the negative, the 2 has to be the positive. Now ask yourself, what would make this 0? Well, from this parentheses, what number would I have to plug in for n to make that 0? Well, negative 2 plus 2 would be 0, so that is one solution. Here, what number would I have to plug in? N equals 3. If I plugged in 3 right there, 3 minus 3 is 0. Alright, number 12 is a greatest common factor problem. So if we look at these two, the greatest common factor is v to the first. If you divide this by v, you would get v. If you divide that one by v, you would get minus 3. How would we make this parenthesis 0? V equals 3 would make that 0. How would we make this thing 0? Well, the only way you can make that 0 is if it equals 0. So v equals 0, v equals 3. And you can check both of these solutions by plugging them back in up here. And you'll be able to see that they do equal 0. Okay, these next two right here, these are swing method problems like we did on the previous page. So you could do these by trial and error. Like, you know that 2 is a prime number, so it's going to be 2k times k. But I don't recommend doing trial and error because 12 has a lot of factors. It's 1 times 12, 2 times 6, 3 times 4. You don't want to have to guess and check on all of those. So let's swing the 2 over. We get k squared plus 5k. Swinging means multiplying, so we're doing 2 times 12, which is that. Now we want numbers that multiply to negative 24, add to positive 5. First of all, if they multiply to a negative, that means 1 is positive, 1 is negative. It turns out to be positive 8 and negative 3. Where did that 2 go? The 2 is in the 24. That means it's still inside these numbers, so we need to get it out. And 8 over 2 simplifies to that. And let's swing this in front since we can't simplify it anymore. And we get that right there. And then we need to solve it. When we solve each of these, this one turns out to be negative 4, because negative 4 plugged in here makes that 0. And this one, if we set it equal to 0 and solve it, we would add 3 to both sides. So we get 2k is equal to 3. Divide both by 2, and you get k equals 3 over 2, or 1.5. And you might notice, let me just scroll up a sec, you might notice that we could have solved it directly right here, because right here 3 over 2 minus 3 over 2, that would equal 0 as well. Alright, last one here is another swing method problem. So this is, you can probably tell, this is a common topic in a lot of math classes, Algebra 1, Algebra 2, Pre-Calc, and so on. We'll swing the 5 over, that's factoring. So m squared plus 16m, 5 times negative 16 is that number there, negative 80. Okay, then we will look for numbers that multiply to a negative 80. So if it's negative that they're multiplying to, 1 will be positive, 1 is negative. And what multiplies to negative 80 but adds to 16, that's going to be 20 times 4. 20 times 4 is 80. By the way, if you can't just tell off the top of your head, many times you can't, what you can do is just make a table and just go down the line. Just come up with numbers that multiply to 80. So 1 times 80, that adds to 79. Sorry, negative 1 plus 80 adds to 79. Negative 2 times 40, negative 2 plus 40 adds to 38. 3 doesn't go into 80, but 4 does. Negative 4 plus 20 adds to 16, and that's the number that we were looking for. So that's going to be plus 20 minus 4. Remember that we swung the 5 over right here, so we need to get it out now. The 5 was here, it got swung into the 80, so we'll swing it, or we'll get it out by dividing by 5. 20 divided by 5 is 4. We can't simplify this any further, so we'll swing it in front, and we get this. And if you solve both of these, m equals negative 4 here, and this one, m equals, or you can look at this problem, m equals 4/5 would be the solution for that one right there. Alright, so that is part 2 of the practice test up to 4.3. In the next part, next video, we will work on these problems right here, which is 4.4.